Have you ever seen a watch with a slide rule bezel like this? Have you ever wondered what they're for or how they work? My name is Daniel, and I'm making this video to hopefully demystify the slide rule bezel, explain how and why they work, and give some examples of situations where they can be useful. I'll be using some tools on my interactive web page to introduce the fundamentals of the slide rule. You can find a link to the page inside the video description. In order to understand how to use the type of slide rule bezel found on many watches, it's helpful to first talk about linear and nonlinear number lines. Linear number lines are probably something you saw in school, and there are certain things they all have in common. First, the line includes and begins from the number 0, and markings for each number are evenly spaced. The distance from 0 to 10 is the same as from 10 to 20, and so on. The change in numbers as we move down the line is linear. If we put two of these lines together and move the bottom line over by 10, the difference between the bottom numbers and the top numbers becomes 10. If we move it over to 20, the difference becomes 20. In this way, you can think of moving right on a linear number line as addition, and moving left as subtraction. Next, let's look at nonlinear number lines. This line begins from 1, and the markings for each number become closer together as you move down the line. In fact, the markings at the end are 10 times closer together than at the beginning. If we put two of these lines together and align the index of the bottom line with the 2 on top, the relationship between the bottom numbers and the top numbers becomes 2 to 1. We can see all at once what all numbers times 2 equals. If we align the index to the number 3, the relationship between the two lines becomes 3 to 1. In this way, you can think of moving right on a nonlinear number line as multiplication and moving left as division. Standard slide rules and watch slide rule bezels work by making use of these properties of nonlinear number lines. By pairing two lines together, we can perform a number of calculations. In order to multiply two numbers, we simply need to align the bottom rule with the first number, move to the second number, and read the results on the top rule. For example, to multiply 2 times 1.5, we align the bottom rule's index 1 with the first number we want to multiply, 2. Then we go across the bottom rule until we reach the second number to multiply, 1.5. The number it aligns with on the top rule is our answer, 3. Division is the same process but carried out in reverse. For example, to divide 7 by 5, first align 7 on the top rule with 5 on the bottom rule. We then go back to the index of the bottom rule, 1, and the number it aligns with on the top rule is the answer, in this case 1.4. Now you might wonder how to perform calculations with numbers that are either smaller or larger than the ones shown on the scale. When using a slide rule, you need to shift the decimal point of your number until they fit into the range available on the rule. Once you have calculated the answer, you then have to adjust the decimal point in your answer to preserve the scale of the original numbers. For example, to multiply 15 and 20, you would move the decimal of both numbers by one place, so you can use 1.5 and 2.0 on the rule. Once you have the answer 3, you need to shift the decimal place back by the same amount, one place for 15 and one place for 20. If multiplying, you add these places together to get two tens places, so 3.0 becomes 300. If dividing, you subtract the places of the second number from the first. For example, if dividing 400 by 20, you perform the calculation using 4 and 2.0 to find the intermediate answer of 2. You then subtract the number of tens places on the denominator from that of the numerator, which would be 2 places for 400 minus 1 place for 20. We then end up adding back one tens place to 2.0 to get the answer 20. In practice, I've found that I can usually just ignore the decimal points altogether and use my intuition to guess the magnitude of the correct answer. Now we're ready to look at a slide rule bezel that you might find on a watch. There are a couple of differences, like the scale running from 10 to 99 and the numbers looping around the watch face. The scale is usually numbered in tens in order to make it more convenient to do time, speed, and distance conversions. So instead of aligning our calculations with the number 1, we would use the number 10 as the index. Depending on the watch, you may also see some extra markings for carrying out conversions between different units of distance, weight, and volume. One thing to note about circular slide rules: when a calculation wraps around the beginning of the rule clockwise, you will need to add a tens place to your answer, and when it wraps around counterclockwise, you will need to subtract a tens place. Aside from these differences, a watch slide rule bezel is essentially the same as a normal slide rule. For the rest of this video, I'll refer to the outer movable rule as the bezel, and the inner fixed rule as the dial. The number lines on the bezel and dial are identical, so you can carry out your calculations beginning from either of them. Next, let's see some examples of how a slide rule bezel can be used. To show you some of the many ways you can use a watch bezel, I've come up with a mathematical story where the slide rule plays a key role. This is a story about Jimmy, who lives in Houston, Texas, and is the proud owner of a Seiko Flightmaster chronograph watch. Jimmy is planning a road trip to Dallas to attend a birthday party for his friend Barry. He and 12 of his friends have decided to pitch in to buy Barry a nice present that costs $480. Jimmy wants to know how much each person will need to chip in for the present, so he'll divide 480 by 13. First, find 48 on the bezel and align it with 13 on the dial. (48) and 13. Find the index 10 on the dial, and it will point to the amount each person needs to pay. Here's 10, and we see that it's $37. Jimmy is what you might call an amateur pastry chef, and has agreed to bake a cake for the party. However, the recipe he's following lists 500 grams of flour as an ingredient, but his scale only measures in pounds. To determine how much flour he needs, we need to use the kilogram and pound unit conversion markings on the bezel. Align the kilogram marker on the bezel with 50 to represent half a kilogram. Here's the kilogram marker, and we need to align it with 50. Then you find the pound marker, which is on this side, and the corresponding number on the dial will tell us it's 1.1 pounds. If we needed to, we could also multiply 1.1 by 16 to convert the answer into ounces. After baking the cake, Jimmy plans his drive to Dallas, which is 240 miles away. He'd like to know how long the trip will take traveling at 75 miles per hour. For this problem, we can use the watch to do time-distance calculation. First, we align the dial's number 60 with 75 on the bezel. On this watch, the 60 is shown with a miles per hour marking, which represents 60 minutes traveled. This way, when we look up the distance on the bezel, our answer will be shown on the dial in minutes. We align 75 miles per hour with the mile per hour marker, and then we find 240 on the bezel, here represented by 24. The dial will show a travel time of 190 minutes. or as this watch conveniently shows us, 3 hours 10 minutes. The next day, Jimmy sets out for Dallas, but halfway there he decides to stop and pick up some lunch and buy drinks for the party. He buys a fancy BLT at a shop for $15 and wants to leave a 20% tip for the sandwich artist, so he needs to multiply 15 by 120%. First, find the base cost of 15 on the bezel. Here's 15. And align it with 10 on the dial. Now if we look up 120 on the dial, or in this case 12, we see that it aligns with 18. So that'll be $18, including the tip. Jimmy pays for the sandwich and then goes to a convenience store to buy drinks. There are 14 people total, and he would like for each person to have 4 drinks. He needs to multiply 14 by 4. Sure, he could probably do this calculation in his head, but where's the fun in that? Align 14 on the bezel, with 10 on the dial. There we go. Find 40 on the dial. And see that it aligns with 56. So Jimmy will need at least 56 cans. A 6-pack has 6 cans, so to find out how many he will need to buy, he will divide the total 56 by 6. Align 56 on the bezel, with 6 on the dial. Which is also our mile per hour marking. It will show he needs approximately 9.5 packs. If we look up 10, we'll see 9.5, or a little less than 9.5. So he needs to buy at least 10 6-packs of cans. Jimmy is still 120 miles from Dallas, and since he spent 10 minutes at his stop, if he wants to keep his original schedule, he'll need to drive faster. To find the exact speed, align the distance to travel on the bezel, 120 miles, with the time he has left on the dial, in this case 1 hour 25 minutes. So we'll find 12 to represent 120. Here it is. And we'll align it with 1 hour 25 minutes. Like that. Then if we look up the mile per hour marker, we'll see that it points at 85 miles per hour. That's how fast you'll need to drive to arrive within this time limit. Jimmy arrives at the party as planned. Barry loves his gift, and the whole group enjoys the cake and drinks. On the drive back from Dallas, Jimmy is running low on gas and decides to stop at a gas station in Madisonville. He wonders what kind of gas mileage he's gotten so far. He traveled a total of 385 miles on 13 gallons of gas, so he needs to divide 385 by 13. First we'll align 38.5 on the dial, right here, with 13 on the dial. Now if we look up index 10 on the dial, we'll see that he got about 29.5 miles per gallon. This concludes Jimmy's mathematical adventure. I hope that you now have a better grasp of how slide rule bezels work and maybe have some ideas for when they might be used. The key idea behind most slide rule operations is establishing a ratio between the two number lines, then looking up a number to find its corresponding pair. You may even find some calculations more convenient than using a calculator, such as converting to and from foreign currencies, or seeing at a glance a variety of prices, or maybe even comparing discounts of various amounts. There are drawbacks to using a slide rule though. One is that your calculations will only be as precise as the quality of the markings, and only as accurate as your eyesight allows. A full-size slide rule will usually have 3 significant digits of accuracy, while a wristwatch bezel this size will probably only have about 2. For example, in our last calculation we calculated a gas mileage of 29.5, but the true answer is closer to 29.6. Another issue is the need to keep track of decimal places throughout the calculation. These are simply limitations of using an analog calculating device, but hopefully this video has shown that a wrist-based calculator can be handy in a variety of situations, especially when a phone or computer isn't handy. Thank you for watching, and happy computing, everyone!